All right, well, hopefully I sound a little bit better. Can you guys hear me better? Awesome, okay, thanks so much. So I wanted you to meet our esteemed panel today and just introduce you to them a little bit. What we're gonna do is really keep this informal. So if you have questions, please feel free to reach out, raise your hand. We're gonna have a little show and tell as well. But I have some really fabulous guests with us today. I'm gonna try to be Oprah as much as possible and ask them good questions, but please feel free to raise your hand if you have an even better question. So let me introduce you to our panel. So first, Sandra Cerrone is our president and CEO of Expert Coatings and Graphics. And Sandy. Her extensive background and expertise in serving the finishing needs for an esteemed caliber of world-class OEMs and second-tier manufacturers has earned her leadership positions in the plastics and finishing industry for over 30 years. Sandy knows her stuff. So thanks for joining us today, Sandy. She has been a program speaker on different topics, including paintings and coatings for plastics, presented by Sherwin-Williams and the Society of Plastic Engineers. So, and Sandy loves to hug her clients and her auditors. So yeah, if you ever become a client. All right, so thanks, Sandy. Next, Chris Strong. So Chris is don't even know Chris, just clap for Chris. Awesome, yes. Chris is the founder and CEO of Oscillate Aerospace, a manufacturing compliance and consulting firm based in Southern California. And as a subject matter expert in metal finishing and coating technologies, we asked Chris to join us because he has over 10 years of experience in both aerospace, defense, and medical device, and even global commercial manufacturing. So he really comes to us from the quality end and auditing. So we're very pleased. So thanks for joining us, Chris. Next is Tim O'Malley. Give it up for Tim. Thank you so much. So we wanted to talk from a coating perspective. So Tim is the industrial account manager for Cerakote Ceramic Coatings. He focuses on new market development for technology by finding new applications for Cerakote in a variety of industries, everything from aerospace to medical devices. Cerakote is a new and growing technology that is disrupting current industry finishes. And if you need to know how to make sushi, Tim's your guy. He used to be a sushi chef. So, all right. Finally, Colin Likey. Colin. Now, I don't want you to rush the stage with Colin because Colin is from SpaceX. And already everybody wants to talk to him because he works for a really cool company. But we asked Colin to join us because Colin has a beautiful background in both aerospace and medical device. He's worked across a variety of different industries, and he has at least 20 years experience in supplier quality management in all kinds of things, injection molding. And he told me on the walk-in today that his dad owned an injection molding company, and they always talked injection molding at dinner. How exciting is that, right? So, so welcome, Colin. As I mentioned, we want this to be as engaging as possible, so we'd like to know who's here with us today. So if you're in the engineering area of your manufacturing facility, can you let us know how many engineers are here with us today? All right, how about sales and marketing? Anybody in that line of work? Just two? My team, that's awesome. Operations, anybody in the ops or quality end of the world? One, very good. How about procurement? Purchasing, and any students or professors here with us today? Awesome, very good. So thanks for joining us again. All right, well, we want to jump right into it and ask a few questions. So Sandy, since ECG really works with a variety of medical device companies, you often say to me, you know, coding is really about functional beauty and applying functional beauty to a medical device part. So can you tell the group here today what you really define as functional beauty?
Thank you, Julie. Well, thanks for everybody for coming today. Well, I'm extremely passionate, super passionate about finishing, doing it for over 30 years. And so not just the aesthetics of a part, which is extremely important. As you know, this is really where the part interfaces with the doctors and the patients as they're being wheeled into a hospital setting, a medical setting. So we really want that patient experience to be awesome. And sometimes their first impression is that the device, that machine that's in the room. So we want it to be aesthetically beautiful. And also we want it to be extremely functional, long term. These items are out on the field. They undergo all sorts of different, things happen out on the field, as you know. And then now with, after the pandemic and all these things, a lot more chemicals and aggressive agents are being exposed to these parts. So we want it to be functional. We want it to be beautiful, and we want it to be bold. So in the past, as you know, parts have been traditionally beautiful versions of white, and also beautiful versions of light gray. And I love them. They're beautiful and they're gorgeous, and there really are a million versions of all these colors. But we're really excited that we see a trend, and that's what we're here to share with you about. And the trend is towards boldness, color, metallics, shimmers, pearlescence. And so for the designers out there, I just want you to be unafraid of experimentation. I actually see some of my beautiful customers for over the years that have that sort of mindset of being bold. And, we could do your part in 10 different colors, and you get to play around and see what the potential could be aesthetically, visually. So we're really passionate about that and help support our customers in that way.
I saw a lot of head nods. How many of you wanted to use bolder colors on your devices and got stuck to being just white? Is that right? Right. We have some show and tell just for you to also dream and design boldly. We have some different color palettes that are going to go around that Sandy and the team at ECG and also Cerakote. But really, it's about helping you, inspire you to think a little bit differently, and hopefully corral that marketing staff that you have. And I'm a marketer, so I understand. We have to corral them to think differently about the brand. So thanks, Sandy. Now, Tim is from Cerakote. He's also seen a bunch of trends in terms of color. Yep. And we'd like to have Tim just talk a little bit more about what you've seen as well.
Yeah, absolutely. So really what we're seeing is a shift from the grayscale that everybody can kind of get their products mixed up in a work environment, whether it's a hospital, an operating room, or if it's a dentistry. They're wanting color, but they're not just wanting color. We're having marketing and engineers work closer together in the medical device industry more than ever before. So when marketing comes in, we're like, hey, we want it red, and the engineers are like, how are we supposed to make that happen? That's really what we're seeing. Is we're seeing a lot more color demand. We're seeing a lot more customization. Companies and brands want to separate themselves from the competition, so they do. They have to be bold. But the engineers don't want to sacrifice mechanical integrity, so that's why we see a lot of more requests for Cerakote, because it is superior in the mechanical properties to like paint and powder. So that's what we're seeing. We're seeing a lot more collaboration in product design and even refurbishment in the field to color without having to sacrifice the actual durability and functionality of the part. So it is beauty and function, just like Sandy said.
Yeah, Sandy, why don't you just tell? So this is one of the ECG customers, and they do this in a variety of different colors. So it's not just a trend; it's actually happening.
Yeah, and you might have noticed on the video. So this is Millennium Dental. They're an awesome company here local in Southern California, and they asked us to play with colors. And we did a beautiful. I mean, there was even like cow prints, and it was awesome. Like what do you call it? The military? What do you call that, Tim?
Like camouflage.
Yeah, camouflage. We did chrome. Like people don't realize chrome is available in liquid finishes now. And so we just loved it because they wanted to be, it's kind of funny. I feel like dentists are a little bit more wilder than doctors. And so we see a lot of just really fun and exciting colors. So this was actually created at our shop. The finish was made and it has like a metallic finish on it. So it's kind of fun because back in the day, maybe the red would have been a trim color or something, closer with the logo. But now we see the alternative where they're going bold with the actual part. And now the branding is actually a little bit more, in the traditional whites or blacks and stuff. So it's kind of fun to mix it up. And they've had a lot of success with that.
Awesome. Thanks, Sandy. So it's not obviously just about the color. It has to be functional as well. So Colin, you live on the other side of the house, right? Device manufacturers, so it's not just the contract manufacturer. And that's really why we wanted to bring you a panel of different people, not just people that understand coding, but people that understand the product usage. So we know at SpaceX, failure is not an option, right? That's not what we need anyway. So why don't you help us really talk about the environment and how that really affects, the coding, excuse me, and how it's applied.
Sure. So basically, I mean, depending on what you're making, I've been in consumer electronics and aerospace and medical, of course, but you really have to think about how the end user is actually going to use your product. Is it a matter of, is it on the outside of a house? Is it in hot? Is it in cold? Is it out by the ocean here? So you get salt spray and all that. So like a lot of these coatings, like you have to think way ahead of time of like, what are we going to be doing to it that you're not thinking of like. Our friends in R&D often like taking, this is the coating we used before, we used on the last product, so we can use that again. But if it's not going to be the same usage for the end consumer, you have to be careful a little bit.
You were telling us a little bit about an ultrasound story where there was some failure in terms of, I think, let me do this. A little bit about what you had in environment failure when you were back in the medical device days. Tell us a little bit about that one.
Yeah, sure. So basically what we end up, we knew hospitals like using these machines, and they put their harsh cleaning on there, or their cleaning chemicals on there. But they changed it on us after we had already released the product. So basically, we were finding out that like not just our plastics, but even like our powder coating and our liquid coating, our paints were actually like peeling off of the products and ended up with like bare metal. So then, of course, you have to consider I'm losing, my medical markings and serial numbers and all these things that we need for traceability. So yeah, it turned scary real quick, and we had to come up with quick solutions to find out what coating can we use instead now, and we didn't really have a backup option at the time. So I would say very early on, come up with two options, always have an alternate.
What about the inside and the outside of the part, right? Because it's different environments, inside and the interior and exterior of the part or the panel of the device. Give us some tips and what you were seeing as trends in the past.
Sure, and you have to think of how the product is assembled. So we had things on the outside that like these liquid paints, it was a silver liquid paint that on plastic and on die-cast parts you could scratch it by looking at it. So of course our techs, our assemblers were scratching it. It was getting scratched during assembly, during shipping, and all of that too. And of course, then we have coatings on the inside for protecting as well. So you really need to look at what your application is going to be.
Awesome. Any questions for Colin on that in terms of environments, issues that you guys have had at all that you want to ask him? I don't mean to put you on the spot. It's okay. All right, Chris, you're up next. So tell us, from the quality auditing side of the house, tell us a little bit about, NASCAP, right, which is really an aerospace certification, but talk about the definition of product impact. And, tell us a little bit about it in the medical device world, because you've been in both, but define product impact for us first, and then share a few stories about how that, from an environment really affects the coating.
So from the aerospace perspective, specifically pertaining to NatCap, we have, I guess what you would call my main job as an auditor, and not a financial auditor, so I'm not trying to look at your records and see if you're hiding money from the government, right? I'm your friend. The biggest task as an auditor is to try to provide value to the supply chain. And the way I provide value to the supply chain is I help identify key manufacturing gaps in your process. Like, it's only so good if you can make one part of something cool, and but what happens when you try to make 1 million of them, right? I'm there to make sure that you have the appropriate capabilities to make 1 million gadgets, 1 million gizmos. And so how I classify a failure is with a nonconformity, right? Where there are two types of nonconformities. There are minor NCRs and there are major NCRs. And I guess the analogy I like to put into this is like, for example, if after this convention I get really hungry and I want to go and order a pizza, and pepperoni pizza is my absolute favorite, right? Now, if I go pick up the pizza at Domino's and it's only a cheese pizza, well, That's kind of a bummer because I really like pepperoni. But at the end of the day, the main goal is satisfied. It satiates my hunger, no problem. So in the same way a minor would be, and it's something that, there's no impact to the process per se, but it's just something that deviates from what was supposed to be a requirement that doesn't have any impact. Now, let's switch gears and talk about a major nonconformity where, for example, let's go with the same scenario. I'm allergic to mushrooms, and they deliver me a mushroom pepperoni cheese pizza. I eat the mushrooms and I die. So I'm not allergic to mushrooms. They're delicious. But in that situation, that's where product impact comes into play, where there's a gap in the system that was not caught at the pizza place, where it could have an adverse reaction, an adverse impact onto the product that's delivered or has the risk of being delivered to the customer.
Awesome. Awesome. What have you seen in terms of things that people are doing to accommodate the challenging environments, so that they can accommodate then the auditing process?
So there's a lot of steps within the process where you can catch these problems, right? Where it's basically the colloquial term is you inspect the quality into the process. However, with current trends and this new current generation of forward thinking of upstream processes versus downstream processes, especially looking at things like AS9100, which is the certification one must get in order to do work for the big prime contractors, SpaceX included in that, with Northrop Grumman, Lockheed Martin, et cetera, where there needs to be processes and procedures in place for risk mitigation. So what does a company do to not only inspect, but to try to plan and design perfection into the product, not only on the design side, but how do we make 1 million of these? Things like first article inspections that are, normally done, but how do we make it more public and more visible to contract manufacturers? For example, if, SpaceX or Boeing, they're going to design something, but if you go into like the Boeing factory, for example, it's going to be more of a, they're putting together Lego pieces, right? Where they're getting parts from everywhere and they're putting together in their factory and not actually making anything in the factory, for better or for worse. Mm-hmm. So it's just all the things that are put in place for risk mitigation and for, hey, let's try to catch the problem before it actually becomes a problem.
Awesome. Sandy, you've talked to me also a lot about the environmental standards and how you see specs come through that potentially are outside of the environmental standards, especially here in California. What are some of those trends that you're seeing and how you help, your customers accommodate some of those changes?
Well, one of the exciting things about manufacturing in California is literally the most strictest state of all the states in the United States to do what we do for a living, coatings. And so I love the fact that for customers that are doing manufacturing process in our state, they're really ahead of the curve than all of our other adjacent places around the country. And what's awesome is because every website, all the OEMs all say that they have a commitment to environment. And so, but not really understanding what that means. So it's really exciting to us when a new program comes into place and we have the opportunity to share with them how they could be not just, compliant, of course, super important in California, but also really be ahead with respect to what that criteria means. And so, a lot of times people don't realize, but, this particularly like this red coating, for instance, it looks identical, feels identical. I could put 5 of them in front of you and they'd all look the same, but there would literally be a difference depending on the coating that we select. Adhesion would still be excellent, endurance, all those wonderful things that we're looking for in a final finish. But it's really important that you understand that. And so we love to teach people what that means and share with them. And it really, I think, makes engineers and designers feel really good, particularly those that are very committed to eco-friendly mindsets for their business. it's really wonderful to partner with them in that regard.
Awesome. Awesome. Thanks. Now, Tim, you represent Cerakote today, but you're also really knowledgeable on both the liquid and powder coating side of the house. So talk to us a little bit about the best situations in terms of when to use liquid, when to use powder, when to use ceramic coating, from your opinion.
Sure, yeah, and I think a lot of that does come down to kind of what Colin was touching on earlier is you need to know your application, but you also need to know your materials and what kind of product you're making. You have to know everything down to the fasteners you're using, to the grade of aluminum that you're using. Liquid and powder, both, a lot of that is driven by cosmetics. Sometimes one wants a 2K solution that has more depth to it. Others just wants, to coat a lot of parts, and they can do it quickly, and they can do it electrostatically, using powder coating. And sometimes it's cost prohibitive. So sometimes paints with primers, aerospace primers and paints are very expensive. But if you look at even some of the requirements for like food grade paints, applications that do require that, they can drive up costs tremendously. Versus if you go through something like a powder coating, which is more of a commodity in today's markets, it can be very cost effective to do a lot of parts very quickly. So really the two, you really just have to pay attention to more of like the materials you're using, whether they're friendly, what your actual product requirements are, whether it needs a primer, whether it needs a top coat, does it need a clear coat, is it going to be outside, does it see weather? Are they going to sanitize it with, really high amount of oxidizers or bleach? Do they come in, it really, it's all variable dependent, but, first is cosmetics, because that's, again, where marketing and design start. And then engineers come in and they tear that apart, and they make sure that, it gets narrowed down to a certain color. And then you can kind of go from there. But, paint has an advantage to be multi-material faceted application. So you can go through a wide variety of polymers and metal. Most of your powder coating is going to be metal based. Some of them require, again, certain particular primers for adhesion, durability, and certain performances. But you have to kind of get down to the nitty gritty when you do, a product like this, where you do have a polymer facing outside. Your whole housing is like 60-61 aluminum. You can powder coat the aluminum and you can paint the front side of it. It just depends on your limitations on color, limitations on depth of color, additives you need into it, or even like in today, especially after the last 24 months, you get a lot of requests for antimicrobial additives. So then you have companies out there looking for the additives they can spin off and whether they're compatible with that type of chemistry. So whether you have a urethane or an acrylic or a polyester or an epoxy, you really can get down to the molecular issue with finding compatible pigments, finding compatible additives to meet this one solid product that you're going to unveil to your customer that does all the things they want it to do. So a lot of variables are in that decision making process, but they're both are great products, but you really have to pay attention to material, its environment, what's going to happen, what's it's going to be exposed to, and then how long do you really want it to be in service.
Well, one of the big trends I don't know all of us thought would happen would be this material shortage, right? So maybe both Colin and Sandy, we'll start with you, Colin. Maybe talk a little bit about what you've seen from innovation just to accommodate the resin shortage and material shortages, and how people are accommodating it, even in where you're at today.
Yeah, so kind of touching on what I was talking about earlier, when we had to go and change, all of a sudden we went from having, a year's worth of inventory of powder to none because it was unusable now. So we had to turn around quickly and didn't have an alternate lined up. So there was that kind of shortage, but obviously we've all seen supply chain issues over the past 2 years, even more so now, actually. So I'm trying to work pretty hard on finding ways to dual source, triple source powders, but even getting them from the same manufacturer can cause all sorts of issues, like at different manufacturing locations. I have one powder being made in Taiwan, another being made in China, and another being made in North America. They're all supposed to be the same, but they aren't. There are just small differences, and some of it is just getting the raw material manufacturers to all be aligned on what they're actually providing, even though it's technically the same, but it's just not. And then getting on to how we test those batches as they come out as well, because they all act different as well.
Yeah, and I would just add to what Colin is sharing. is that, just the most minute thing could make a difference. So particularly now when you see shortages in resins and materials, but even things like the metallic flake in your finish. Maybe it was a silver or a gold, and suddenly they have to replace it with something else. And the way the light hits on that, and once it's sprayed, it could make a subtle difference. And when you have mating parts that are being manufactured from other locations, those are things to consider. I know that with us, what we've seen recently quite a bit is because now injection molders are having to get qualified in other resins because particular resins aren't available right now. And so we're seeing a lot of parts that perhaps were never meant to be painted. They were supposed to be, out on the field, raw, a textured plastic of some sort. And now they can only get it in black, but the unit's supposed to be white. So we're seeing a lot of resins coming in where we're doing color conversions. And literally because production lines really all over the country right now are on hold for that one single item. So they'll be overnighting pallets to our shop, and we're suddenly, taking them. Of course, we qualify the finish first to make sure that it meets the criteria that it needs to, and that when we go through a qualification process. But then after that, we'll coat it with whatever color, and then they put it all together out on the part, and then they're back in business again. So we've seen a lot of last minute saving the day by trying to do that.
That mating part comments is actually really important too, because even if you're manufacturing them in the same place, you're coating them in the same place, we have inventory that's been sitting there. And if we're not doing a perfect FIFO system where everything came in at the exact same time from the same batch, now I have to sit and sort through materials. And I've spent weeks at least of my life sorting through, 100,000 parts of which ones match, even though they're supposed to be the same color.
Yeah, it's a really, really challenging environment. So let's switch to actually graphics now, because obviously we have a beautiful part. It's beautiful color, right material. We don't sort of 100,000 parts. I can't even imagine. I hope you drink after that. Let's talk graphics a little bit. So we'll stay with you, Colin. So, we talked environment and how it affects the coating, but obviously now we have branding, we have UL labels, we have all kinds of different labels that get applied. Talk to us a little bit about the environment and how that also affects, the labels and all of the graphics that need to go on any type of product.
Yeah, absolutely. And it goes into kind of the criticalities, things that Chris was talking about. If I lose my nameplate off a machine, okay, nobody's going to get hurt, nobody's going to be affected. And maybe they don't know which machine it is anymore, but they've also probably been working on it for 10 years or 20 years. So those things don't or shouldn't bother us as much. But of course, there's some marketing people out there that
get a little angry.
They got some heartburn over it, sure.
Right.
But then there's the more critical things, and kind of what I brought up earlier, the barcodes on the systems on the outside that slowly chemicals are dripping over them throughout the years, or all of a sudden one wipe and takes away some instructions. I've had pad printing that has been wiped off from abrasive chemicals. So between serial numbers for traceability, instructions for the actual user, and labeling, obviously there's criticality issues, but they're all important. They're there for a reason.
How do you see things solved? We know it's an issue. So what have you seen for good solutions to some of those issues?
Hopefully a lot of developmental work up front of finding out, again, how is it going to be used, and do I know which chemicals are going to be used on this, and is this going to be able to withstand that? But unfortunately, sometimes again they'll change the chemicals on you, or move the goalposts, as we do.
Awesome. Well, that kind of leads into Chris. You look at a lot of applicator organizations and really around the kind of the surface preparation, treatment process, and maybe you can give some insights for anybody out in the crowd that might be, going to a supplier even to do their own audit. What are the types of things that people should look for as they see, is the preparation a good process that would withstand, things that we expect?
Yeah, absolutely. There are a lot of things to look for, at least on the qualitative level, for things like, okay, well, but what are the properties of the material? How do they look after surface prep? And what are the chances that something is going to stick to it after the bake operation, after whatever post-processing, what have you? And at least according to NADCAP guidelines, one of the things that I need to check for when I go into a facility is if we do a surface prep for a part, let's say it goes through a degrease, an ultrasonic, even like a laser prep or something like that, is the supplier, do they have the right flow down, the right due diligence to check it after? Or is it they dip the parts in a cleaner and then immediately goes into a spray booth, they spray it, and then, oh no, crap, I have problems. And one of the main qualitative steps that's kind of a quick and dirty, easy way to see the surface validity is, of course, the water break free test, right? Where there's a set procedure inside of the work instructions that an auditor, that an operator, a manager, anyone, doesn't matter what your job title is. You can go in, look at the documentation, see, oh, hey, they're going to do a check of the process to see if they were clean. And if it says if it's not clean, then it goes back into the cleaner, goes back into the, an alcohol wipe or what have you. So that's the first thing I'm going to look at. And the other thing I'm going to look at too is how critical that surface adhesion has to be, how crazy that surface energy must be. So are they doing some kind of, are they testing the water tension on the part? Like, are they using a dyne meter or something like that, wiping it across to see how much it beads up? And not only that, but is the operator just doing that on his own? Or is he actually reading it from a set of instructions? Is he reading it in a procedure and doing it? And not only that, if we want to expand on that, are these kind of tests flowed down, not from the work instructions, but built into the actual manual of operation? So is it something that they require to be verified? Is it something that they require records of to see if there's any kind of trend analyses that someone can come in and look at? So there's a lot of things that can build in, that you can bake into the process to make it as bulletproof as possible.
Awesome. Sandy, there's another different type of, surface treatment, and maybe you can touch on a little bit about, the plasma treatment versus traditional alcohol cleaning from your perspective, and help give us a little bit of insights into that as well.
Sure.
I think you're good.
Fine. Okay. Well, that's everything. And I think after I share a little bit about this, I'm sure that Tim has some great comments about this subject as well. Really, the preparation of the substrate is the most important thing. And we really want that bond with the top coat. And so whatever it may be, like with graphics, for instance, we do often use something called plasma treatment. It's a heat flame treatment. And what it does is it's like a chemical conversion to the exterior of the substrate, which allows any graphics artwork to really bond into the part. But this goes across the board with the coatings as well. And so we want to make sure that whatever it requires, to maintain the integrity of that relationship, or with intercoatings, that exists. So it's an extremely important part of the process, and just really prepping that substrate correctly. And people that skip that step, well, that's a failure. It's a failure. It'll fail out on the field eventually. So we feel very strongly about it. It's a step that we don't skip. And yes, there's a cost involved with prepping it, but we won't do it without it, because our name's on it, and it's just too important. And I know that Tim has some strong comments about this.
Yeah, they're strong because Cerakote won't work unless you follow everything to a T. So there we do get a lot. It is prep intensive. So if you do skip a step, you lose adhesion, or you lose durability or chemical resistance. There are critical aspects to the surface prep, or making sure that you use the right media grit, 100 grit aluminum oxide or garnet sand. And if you use something that's too rounded, you could lose adhesion. So you went from 5B to 3B. Now all of a sudden you went below the spec that the customer asked for. So and cleanliness is probably the biggest part of that too. Everything down to your fingerprint oils can affect whether that coating will stick to even if you have the right surface profile, the mechanical profile on the surface, your fingerprint oils on there, you'll get a blotchy section that will peel off. So cleanliness is absolutely critical, regardless of whether you're using Cerakote, which is vitally important, or if you're doing paint or powder or even any kind of plating. You have to go to an absolute procedure and SOP to make sure that everything is followed, because that's where you're gonna get the actual manufacturer standards put in place. So when we say like 9-inch pencil hardness, if you follow everything to a T, that's what you get in return. Deviating from that, you have mixed results. So yeah, it's very important.
Can you, since you're already talking, Tim, can you tell us a little bit also about the trends in the 3D laser etching or burn etching, it's called? I know we got a couple samples we want to pass out just so people can see a little bit more about the application.
Absolutely. So, at Cerakote we identified that not only do we have a great product, it's mechanically sound, it's very durable, it can handle very high wear environments, it's very chemically resistive, and it's a direct metal coating. So there's no primers involved, there's no top coats involved. It's a single layer, very aesthetically pleasing coating. But what we do get a lot is, hey, I want my product to be customized, and that's where you can drive cost up tremendously. And to do customizing, before we did laser imaging, doing any kind of custom work, you were laying down stencils, you were doing multiple layers, meaning flash coats in and out of an oven. So you're adding not only labor, you're adding cost, you're adding masking, and it can really just drive up and just not make customization feasible. But it wasn't just that I want my product customized. I want 100,000 of them every month done, and that's where it really got scaling. It was really tough. So we invested a lot of our time into 3D laser imaging. So we built our own 3D 5-axis laser where you can take a completed Cerakote part out of inventory in one solid color, put it in a laser imager, and you can customize it to whatever you want it to be. We have a lot of defense and a lot of retail firearm applications for our coatings. And a lot of what we got is, I want 3-color, 4-color camos, and I want them instantly. But we need 3,000 per month. And if you've ever laid down stencil trying to mask and put it into an oven and take it out, boy, man, it's hard just doing one part. So being able to do, keep up with production 5,000, we had to come up with something that was almost instantaneous. But at the same time, they didn't want to sacrifice mechanical integrity. So with our laser imaging, we've been able to tune in our lasers to where we're actually just modifying the pigments inside the resin. And not removing the coating, which is typically what people do. They go and they etch off the top layer, or when they get to the substrate, now you have a bare substrate. They still wanted all of the chemical resistance, they wanted the durability, and they want the aesthetics all in one package. And we're able to do that now, and be able to scale it to whatever product they would want with Cerakote, they can get it. So it's been a tremendous effort on our engineer side, and our engineering department. It's taken the better half, about 3 years to get it down, but it's pretty excellent to have customers come to you and be like, I really like your coating, I love everything it does mechanically, but we really wish we could do this type of pattern or have these type of instructions, and be able to deliver it almost not necessarily instantly, but fairly quickly in comparison to their other options. It's been able to kind of set us apart in a lot of different areas.
Cool. Well, we got about 4 minutes left. Anybody have any questions from this group? Awesome. Thank you.
Hi, I had a quick question. So why do you think computational simulation is not being used as much when you're trying to eliminate ambiguities in your process? Like, I work in medical device right now, but in the past I have worked for the Kennedy Space Center, developing their thermal barrier coating system. So I came from the grad school background, so I was doing grad stuff all day long. Mathematical and physics-based simulation in the current computational world can solve a lot of issues. And economies like China and Russia is doing that because they are resource constrained. So many of these issues with doing 5 prototypes, when you have resin supplies being an issue, you can do the whole thing in a virtual reality parametric study and eliminate physical prototyping completely. So is this a talent issue? Is this like a cultural issue that the industry is not really willing to do computational simulation? So just wondering.
Yeah, I guess that's a really good question. A lot of it is going from a digital model and then doing it to real life. So if you can make prototypes all day long and they come out perfect, and you have a lot of control over that. It's right in front of you, and with additive manufacturing, you could have them in an hour, right? Versus when it goes to scale, when it actually goes to production, all of your models that you had, there's still variables that haven't been figured out just yet. A lot of that can be human driven. That's why a lot of people are finding automated solutions. They're just trying to take that element out of the equation so that when it does go from digital model and it goes into a scaled production for a product, that all of those variables have already been considered, they've been weighed, they've been completed. But I think what we're still trying to bridge that gap between the digital space and what real world circumstances kind of play into, because even if a model specs in like ABS plastic is the best material you're going to use mechanically sound for this part, what happens when you run out of ABS? Do you have a backup? You know, they sometimes won't take that into consideration. So you still have to plan with, you know, your best intentions of real world circumstances for supplies or materials or backups, just because that's Murphy's Law. What can will, right? Yeah.
Any other questions?
And I just want to say, like, modeling and simulations will only get you so far as well. And especially on the scaling thing, yeah, yes, I can make 10 of them. Hey, they all looked good. So yeah, cool, turn it on and start production. And then all of a sudden, well, now that we're trying to make 1 million of it, it's just not working out.
And I would add too that many times the goals of the marketing and the designers are different than the goals of when it goes into production. And so many times, you know, the designers might have this idea and plan, and maybe, you know, and it's just like if you're, you know, trying to figure out a new landscape for your front yard. You know, you're like, oh, I want the waterfalls and I want the palm trees, and then they tell you how much it costs, and you're like, oh, a cactus will be fine over here, you know? Yeah, and so a lot of times, so what's wonderful is when you're able to marry those two things together and come up with both the beauty that you had in design phase, but also that it's going to make sense in production, because those buyers have their own agenda that's an extremely important agenda, and it's making sure that they could bring that product to market at the best price possible. So, you know, it really, a lot of times there's a disconnect between the two worlds. And so we always love to try to merge them together, because we know eventually, very soon, it's going to go into production, and that buyer is not going to be happy with the original vision. But it's not impossible to have it as long as we talk about it early on. I think that pre-planning is so important, and we love it when we talk to customers very early on in the idea phase and the conceptual phase, because we really help you to save money at the end. So it's very important.
Cool. Well, we're at time. Oh, let's do one more.
Yeah, just real quick. What goes into like writing a specification for a coating around durability? What sort of things do you call out? Is it just hardness, and like how do you verify that you're meeting those specifications?
And I'm probably going to let you answer most of it, but I mean, I would like the main one I focus on like the supplier development, supplier quality side of things that I work on is the color call outs in there and like the LAB values. And obviously you want to add in on the drawings, what kind of testings does it need to be able to take? But for
so being a manufacturer of coatings, you know, we get a lot of engineers, we get a lot of even designers that'll come in and they say, hey, I really want this red coating, and this is what it's going to go on, and this is what I want. Really what we try to do is just go, okay, what's your wish list? What environments are going to be in? Like, for instance, like aerospace interiors. A lot of those have a lot of specifications you do need to meet. They can't be toxic. They can't burn or catch on fire. They can't combust. Okay, so we need to check that box. If they do burn, they have to be non-toxic or below the limits. Okay, so we need to check that off the box. What materials are you applying it to? Does it adhere to 6061 versus 7071? You know, how much wear is this? It's going on an aisle where a cart's going to hit it. So we really have to, you have to kind of dream up what the part's going to do in worst case scenario and best case scenario, because there's areas where it'll never be touched, even if they have like stringent requirements. But if you're writing a spec for a coating, you really want to sit down with that engineer, or you want to sit down with yourself and go, okay, I have to think worst case scenario about everything. So my durability or all of my requirements are going to be all the way up here. In reality, once you start building that picture, they may come down or they may go up. But you really have to take into consideration, you know, your material substrates, what you're making it out of, the environment it's going to be in, who's going to handle it. COVID taught us that chemical resistance is pretty important, especially when everybody started cleaning everything with bleach. Things don't hold up to bleach very well, especially like your typical paint and powder coatings. It'll peel right off. Is that ever going to happen? So you kind of have to build up in requirements of its environment, its usage, and then how really its service life. Is this like a 2-use product? Is this a 10-year product? Those are things you really have to take into account. But There are standards that you follow when you are looking at coatings. Like there are plenty of ASTM standards that are absolutely universal. You will never get away from them. Crosshatch adhesions, probably one of the most common ones for adhesion testing. Pencil hardness for scratch and gouge durability. Tabor wear cycles. I mean, these are all very well practiced. And so if you get into going, it's not going to see a lot of wear. So Tabor abrasion may not be important to you, but I need something that's going to be durable. Let's find something with a good pencil hardness. Okay, now I need something with good chemical resistance because it's going to be cleaned all the time. What kind of chemical testing have they done in finding those standards? But yeah, so I mean, if you look at ASTM, and that's typically what we use because that's the most common through paint and powder coatings that you'll see. But that's a good place to start, is just looking at what available standards are there, what do they actually test, and then how does that meet and fit to my part.
Sorry, I have to cut you off because I'm getting the cue that we're going to get pulled off the stage here. Okay. So here's what we're going to do. Thank you, everyone, for attending our panel today. We hope it was helpful for you, that you'll think differently and design boldly. Our panel will be over here to the right. Please feel free to come up and ask questions, and these guys will still be here. So please do that. Thank you to Colin and Tim and Chris and Sandy so much for the information.